The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
So I'm going to solve problem number 2 in exercise set number 3. And this particular problem says, determine whether the following represents functions. And we have 4 different parts here, A, B, C, and D. And we're going to work through each one of these parts. We're going to go through them separately. But before we do that, before we can answer the question, we need to know what a function is. So basically this problem is asking us, what is a function? And so I have written here in red the definition for a function. And basically a function states that for every x value, there is one and only one y value. Okay? And so what does that mean? Basically, if you have a graph here and you have your x and your y, it's basically saying that if you can, and this would be your graph, this is saying that if you draw a straight line through your graph and a straight line, vertical line, intersects your graph at more than one point, for example here and here, then that is violating the definition of the function, because you see for an x value, we actually have one y value, two y values, okay? And so our definition says for every x, there is one and only one y value. So one way to test if something is a function is to either determine whether this statement is true or through a vertical line test, okay? So we're going to go through each one of these parts, keeping the definition and the vertical line test in mind. And the first part, part A, says a graph that intersects the y-axis in 2 places. For example, 2 y-intercepts. So if we have a graph that intersects the y-axis in 2 places, well, the y-axis basically serves as our vertical line. So basically, if this is the y-axis and if it intersects the graph, if the y-axis intersects the graph in 2 places, we know that the x value is going to have at least 2 y values. So this is not a function. So for part A, this is no. Okay? For part B, this says a rule that associates a student with his or her current most favorite song. And when we read this statement, we see that we can set up a coordinate system that basically associates a student to a current song. And if we do that, we will have our students on the x-axis and the favorite song on the y-axis. And if we have any number of students, each student is going to have only one favorite song. So we know that each student is only going to have one and only one favorite song. And so yes, this would be a function relationship. Okay, so the next part is part C. And this says a rule that associates to a given time the distance from a swinging pendulum to its lowest point. Okay, so now we're associating a time to a distance. Okay, and we're talking about a pendulum. So when we're talking about a pendulum, at any point in time, okay, the distance between where the pendulum is and the lowest point, okay, is determined like this. Okay? And so at any time, the distance between where the pendulum is and the lowest point, it can only have one of those distances. Okay? And so let's say at time 5 seconds, it's here. Okay? So it can't be in more than one place at one time, and so it can only have one y value. And so this is actually going to be a functional relationship. So yes. Because at any point in time, it can only have one distance away from its lowest point. Okay? All right. The last problem states that a rule that associates to a given distance the time at which a swinging pendulum is that distance from its lowest point. So now we're associating not a time, but a distance to a time. Okay? So if we have now our distance on the x-axis and our time on the y-axis, well, we know that, let's say this is this point to the lowest point is d1, and this point to the lowest point is d1, and this point to the lowest point is d2, and this point to the lowest point is d2. Okay? We can say that for d1, which is this distance here, okay, let's say this distance is 5. Okay, that distance is 5 here. What time is going to be associated with that distance 5? Well, it's going to be associated at one particular time, and it's also going to be associated at another particular time. Okay, so your pendulum is swinging back and forth. At one time it's going to be D1, and at another time it's going to be swing back to also be D1. So actually we're going to have 2 times where that time is going to be associated to that distance. So, and that's going to be the case for each distance that we have. So you see that basically if we draw a line, vertical line, through those 2 points, they cross the same, they cross the plot in 2 different places. And so we know that that is not a functional relationship, because in this for every x, there can only be 1 and 1 y value, and we see that there's more than 1 here. And so this is not a functional relationship.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.